Let's do this first review problem. We have a play it roulette. If you win $8 with probability 4/38, and you lose $1 with the remaining possibilities, let's figure out the expected value of x and the standard deviation of x. So first off, the expected value of x, also commonly called mu, that's equal to 8 times 4/38, the possible value of x times the probability, plus the other possible value, which is -1, times the probability of that happening, which would be 34/38. And so that simplifies as -2/38, which is -1/19. To get the standard deviation, the first thing that we need to figure out is the expected value of x squared. So that'll be equal to 8 squared times 4/38 plus -1 squared times 34/38. And I'll use Excel down here as my calculator. So first off, the mean mu is equal to -1/19. We just worked out. Expected value of x squared is equal to 64 times 4/38 plus 1 times 34/38, so 7.6316. And so finally, the standard deviation will be equal to the square root of expected value of x squared minus mu squared. So that'll be equal to the square root of what we just got, 7.63158 minus -1/19 squared. And so sigma will be equal to square root of expected value of x squared minus -1/19 squared for 2.762. Okay, so that's part 1 of this exercise. Part 2, suppose that he plays 2,500 times. Find the expected value of y and the standard deviation of y. To do this, let's clear off the work that we've already done here. And for this is a sum problem, and so I need the expected sum and the standard error for the sum. The expected sum will be equal to n times mu. That's the formula for expected sum. So 2,500 times -1/19. And so let me make a column over here that the expected value of y is equal to 2,500 times 1/19, so -$131.58. The standard error, the standard deviation of y, the formula is sigma times the square root of n for this sum problem. So that'll be 2.762 times the square root of 2,500. Which works out to be so the standard deviation times the square root of 2,500. And so that works out to be $138.10. So you expect to lose about $132, give or take $138. Finally, suppose that he plays 2,500 times. Find the probability of coming out ahead, of having a positive net gain making more than $0. So the probability that y, the sum, is greater than 0. Now, because I have a large number of trials, the bell curve applies, and so this will be approximately equal to the probability that a standard normal random variable, z, is bigger than 0, the observed sum, minus the expected sum of $131.58. That's what's expected, as we see down here, divided by the standard error for the sum, which we worked out to be $138.10. So the probability that z is bigger than, so the z value that we have will be equal to 0 minus the expected sum divided by the standard error, which is 0.953 basically. And then from this point we use Excel or else the calculator or else the table that will be provided to figure out the probability of this event. And so finally the probability, in this case it will be 1 minus norm s dist of that z value. So we conclude we get a probability of about 17%. And so that concludes this problem.